Alright, in this presentation, we're going to go ahead and look at some application problems involving multiplying and dividing fractions and mixed numbers. So let's go ahead and jump in. Let's start off with our procedure. The first thing we want to do is read through the problem and look for key words or terms or phrases that tell us whether we're going to be multiplying or dividing. For problems involving mixed numbers, estimation may help you determine not only an appropriate answer, but which operation to work with. From there, we want to set up a mathematical model. We're going to solve the problem, and finally, check that your answer makes sense in the context of the real world. So let's go ahead and look at some examples. So example A, we have Lois Stevens gives 1/10 of her income to her church. 1 month she earned $2,980, and we want to know how much did she give to her church. So when we do this problem, let's start off by analyzing this. I see this word of here, and remember that of implies multiplication. So what we want to know is, do we know her income? And in fact we do. It's $2,980. So in order to solve this problem, we want to multiply 1/10 times $2,980. And I'm going to put this over 1. Alright, to go ahead and simplify this, we can cancel out the 10. Both of these numbers are divisible by 10. And an easy way to divide by 10 is just to cancel out zeros. And if we go ahead and multiply straight across, we get 298 over 1, or just $298. Now, does it make sense that she can give $298 to her church? Yes, it does. She has $298 to give. Now, if you had set this up as a division problem, you would have ended up with $29,800. And is it possible for her to give $29,800? For that one, the answer is no. All right, so let's go ahead and look at another example. Of the 39 students in Mrs. Martin's high school economics class, 2/3 plan to go to college. We want to know how many plan to go to college. So this is another one that implies multiplication. We have of the 39 students. And in fact, this is 2/3 of the 39 students plan to go to college. So we can again rewrite this to where it says this. And again, remember, of means multiply. So we're going to get 2/3 times 39, and I'm going to again put 39 over 1. If we go ahead and cancel, my 3 and my 39 are both divisible by 3. We get 1 and 13. And now if we multiply straight across, we get 26 over 1, or 26 students. Okay, so those are some examples involving multiplication. Now, for instance, on example B, again, if you get more students planning to go to college than you have students, then you do have an issue and you want to go back and retry the problem doing something different. All right, let's keep going. Example C. In her will, a woman divides her estate into 6 equal parts. 5 of the 6 parts are given to relatives, and of the 6th part, 1/3 is given to the Salvation Army. We want to know what fraction of her total estate goes to the Salvation Army. So one thing to note here is 5 of the 6 parts, do we care about them? And the answer is no. So this sentence, we don't even need to really worry about it. What we care about is that last 6th part. And it says 1/3 of it is given to the Salvation Army. So again, this is a multiplication problem. We want 1/3 of the last 1/6. And if we multiply this, we should get 1/18. All right, example D. We have an oil painting, measures 3/4 feet by 2/3 feet. We want to find its area. So one thing to note is area. This is an application of multiplication. Area is equal to length times width. So in order to solve this problem, we are going to multiply 3/4 times 2/3. We can cancel our 3's. They are both divisible by 3, and we get 1 and 1. 2 and 4 are both divisible by 2. We get 1 and 2. And now if we multiply straight across, we get 1/2. Now we'll get into this in more detail later, but the units for area are always going to be square feet. Because note here we are multiplying feet times feet, and feet times feet is feet squared. Okay, last couple of examples, or next couple of examples. We have how many 5/6 ounce dispensers can be filled with 40 ounces of eye drops. Okay, so for this problem, one thing to note is we are working with a total of 40 ounces. And from that, I want to know how many groupings of 5/6 can I remove from that. So this is a division problem. I want my total first, so I'm going to do 40 divided by 5/6. So as this is a division problem, the first thing we're going to do is copy dot flip. (40) and 5 are both divisible by 5. We get 8 and 1. And if we multiply straight across, we get 48 over 1, or 48 dispensers. Now for this problem, note that each dispenser is less than an ounce. So you should be able to fill it up more than 40 times. If your answer is less than 40, then you have an issue. All right, next problem. We have the top 12 employees at Mayfield Manufacturing will divide 3/4 of the annual bonus money. What fraction of the bonus money will each employee receive? Okay, well, this one's pretty easy. We are specifically told that they are going to divide 3/4. All right, so let's go ahead and see what we can do here. So what number would you like to have first? Some of you might say 12. And let's see what happens if we do that. If we divide 12 by 3/4, we're going to copy dot flip, so we get 12 over 1 times 4 over 3. We can cancel, and we get 16. Now, I don't know about you, but I have an issue with this because basically this is saying that they're going to get 16 times the total annual bonus money available, and that would be incorrect. And so the other thing is note that it says what fraction. 16 is not a fraction, and so we have an issue with that as well. So what we need to do is we want to actually start with the annual bonus money, or the fraction of the annual bonus money. And we want to divide it by 12 people. So if we do this, we get 3/4. We're going to copy dot flip. We can cancel. 3 and 12 are both divisible by 3. We get 1 and 4. And we get each employee will receive 1/16 of the bonus. That answer makes sense in the context of the problem. Okay, so let's go ahead and look at some problems involving mixed numbers. It says, for example G, if one car requires 2 5/8 quarts of paint, find the number of quarts needed to paint 16 cars. And so when you're looking at this problem, one of the things you can do is you can use estimation, not only to estimate your answer, but to possibly help you determine what your operation is. So if we estimate, let's say one car (2 5/8), that's going to be about 3 quarts. And we want to know how many quarts. For 16 cars. So each car needs 3 quarts. And so what we want to do is we want to multiply 16 times 3. So let's go ahead and do that with our exact numbers. So we're going to multiply 16 cars times our 2 5/8. We are working with mixed numbers, so I do want to convert into improper fractions. I'm going to write 16 over 1. 2 and 5/8. If we convert this to improper, we get 8 times 2 is 16, plus 5 is 21. We keep the same denominator. And now let's go ahead and cancel. 16 and 8 are both divisible by 8. We get 1 and 2. And if we multiply, we get 42 over 1, or just 42. We include our correct units, so we get 42 quarts. All right, let's look at example H. It says a dome tent for backpacking requires 7 1/4 yards of nylon material. How many tents can be made from 21 3/4 yards of material? So if we estimate this, let's just say 7 yards per tent. And we want to know how many tents. If it doesn't really matter what you round this to, I'm going to say 22 yards. So note here, we are being asked how many tents can be made from 22 yards. And so what we're wanting to do is 22 is the total number of yards we have to work with. And we're wanting to know how many times does 7 go into 22. So this is a division problem. So now let's go ahead and work with our actual numbers. We do want to divide. We're going to convert to improper fractions. 4 times 21 is 84. Plus 3 is 87. I'm hoping. Over 4. Divided by 7 times 4 is 28, plus 1 is 29 over 4. All right, we copy dot flip, so we're going to do 87 over 4 dot 4 over 29. I can cancel my 4's. And I don't know if 87 and 29 have any common factors, but what I'm going to do is I'm going to go ahead and divide. And I will tell you, I tried to pick the nicest problems possible on the homework, but this book picks nasty numbers. For instance, this example here is not exactly my favorite. All right, so how many times does 29 go into 87? I think it goes in about 3 times. So if we multiply, 3 times 9 is 27. 3 times 2 is 6, plus 2 is 8. Okay, so it does go in evenly. And so our final answer is going to be 3. What are we making? We are making tenths. All right, so that takes care of our application problems. Again, just make sure that your answer makes sense in the context of the real world. Go ahead, do the homework, and then the next thing that we're going to be looking at is we're going to get into adding and subtracting fractions and mixed numbers.